Today, we're going to talk about something pretty wild. We're looking at how a technology that we usually associate with video games is now, literally, building our real world. Yep, we're talking about virtual reality and how it's shaking up one of the oldest and most essential industries on the planet, construction. So let's dive in and see how a virtual blueprint is creating a much better physical world.
To really get why VR is such a game changer, we have to start with a really basic question. Why is building stuff so darn hard? I mean, it seems simple on the surface, right? You get a plan, you follow the plan. But in reality, it is an incredibly complex dance between materials, people, schedules, and, physics.
For centuries, the construction industry has been wrestling with the exact same big, expensive problems. Any little mistake means costly rework. Job sites are, by their very nature, pretty dangerous. And there's almost always this huge gap between what an architect designs and what a client is actually picturing in their head. These have been the stubborn challenges just waiting for a new way of thinking.
And that new way of thinking, well, more and more, it's virtual reality. So what is it, really? Simply put, it's a totally simulated digital world that you can actually step inside. This isn't about just seeing something on a computer screen. It's about being in it. You can look around, walk around, and interact with things like you're physically there. Okay, so how does this actually help? Well, the first major problem VR completely demolishes is what I call the vision problem. It's all about closing that massive gap between a flat 2D plan and a living, breathing, three-dimensional reality. I mean, just think about it for a second. For hundreds of years, the main tool for explaining the design of a massive, complicated building has been a piece of paper. Even with fancy 3D models on a monitor, you're still an outsider looking at it. You're not standing in it. It takes this huge leap of imagination that not everyone can make. And that leads to this interpretation gap. On one side, you have the client, trying their best to piece together a mental picture, but it's full of guesswork and uncertainty. On the other side, the architect has this crystal clear vision of the scale, the light, the flow of the space. VR becomes the bridge. It lets the client literally step out of their uncertainty and right into the architect's vision. And the process itself is just brilliantly simple. First, a super detailed digital model of the building gets made. Then, and this is the cool part, the client puts on a headset and literally walks through their future house or office. They can give feedback right then and there, intuitively. And that means the design can be changed and perfected with total confidence before a single cent has been spent on real materials. This really gets to the power of human scale. With VR, you don't just see the dimensions of a hallway on a blueprint. You stand inside it and you feel if it's too cramped. You don't just see a square representing a window. You can actually experience how the light is going to pour into that room in the morning. These are the kinds of make or break details that are almost impossible to get from just a drawing. Now, it's not just about what the client sees. VR is also solving two of the biggest on-site nightmares: coordinating all the different specialized teams, and, of course, keeping everybody safe. I want you to imagine a meeting where the conference room is the building that you're working on. That's what VR does. It creates this shared digital space where everyone, the architect, the structural engineer, the plumber, the electrician, can all meet up inside the model, no matter where they are in the real world. And one of the biggest wins here is something called clash detection. In the virtual model, you can immediately see where a big plumbing pipe is about to run smack into an air duct. Finding that problem right there in the digital world before any materials are even ordered, well, that's a massive, massive cost saver. But, maybe the most profound use for all of this is in safety. Construction sites are dangerous places. That's just a fact. VR gives us a revolutionary way to train for those dangers. It lets workers practice really complex, risky jobs in realistic environments that are completely 100% risk-free. Think about it. You can let a new worker experience what it feels like to be on scaffolding 30 stories up. You can simulate a live electrical hazard or a fire and train people on how to react instinctively without anyone ever being in real danger. Building that kind of muscle memory is invaluable, and it can absolutely save lives.
So, what have we got? We have better designs, we have much better collaboration, and we have safer workers. That's all great, but what does this all add up to? Well, it all comes down to the two things every single project lives and dies by: time and money.
So, where does all this value really come from? Well, the biggest piece of the pie, a whopping 40%, comes from reducing rework. That means catching all those design flaws and system clashes before they ever happen in the real world. Decisions get made faster because everyone is literally looking at the same thing. And of course, improved safety means fewer costly accidents and delays. It all just adds up. Now, as we start to wrap this up, it's really crucial to understand that VR isn't the end of the story. Not by a long shot. It's a star player in a much bigger digital transformation that's happening across the entire construction industry.
You've got to see that VR isn't some isolated gadget operating on its own. It's really a foundational piece of a whole ecosystem of technologies, and they're all working together to make the entire process of building something smarter and more connected than ever before. Think of it like a digital construction dream team. You've got VR, and its power is to let you immerse yourself in the digital model before it's real. Then you've got its partner, augmented reality, or AR, which can overlay that same digital information right onto the real-world job site. And finally, you have the brains of the operation, artificial intelligence, or AI, which can analyze all the project data to predict problems and optimize schedules. When you put them all together, you get this seamless flow from an idea all the way to a finished building.
And that leaves us with one last, kind of mind-blowing thought. For all of human history, we built things first, and then we fixed our mistakes. Now, for the first time, we can perfect them in a digital world before we start. So, if we can digitally design, test, and walk through an entire skyscraper before a single ounce of concrete is poured, what does that mean for the future? Really, what can't we build? It seems like the only limit left is our own imagination.